storm never stops the stallion. Weather is irrelevant to the king. Is American heavy lift supremacy.
We begin our journey outside the massive aerospace facility, where the CH-53K
Only authorized technicians and engineers enter this restricted zone, where one of the world's most powerful helicopters dress protocols ensure safety, cleanliness, and precision during every stage of the CH-53K's construction.
Remove dust and contaminants before entering the precision machining sections.
Titanium, carbon fiber, and advanced composites form the backbone of the King Stallion's extreme durability.
The massive 7 rotor blades begin as precision-cut composite sheets, engineered to handle extreme lift loads.
The edge with the laser guide. Looks good from here.
Check the tension on cell 4.
Vacuum infusion system saturates the carbon structure with resin, giving the blades immense strength.
Rotor blades cure inside a massive autoclave, bonding composites under heat and pressure. After curing, CNC machines trim and contour each blade to aerodynamic perfection. Balancing ensures the 7-blade system rotates smoothly at high loads and extreme speeds.
The rotor hub, one of the strongest parts of the helicopter, is forged under thousands of tons of pressure.
Computer-guided machining sculpts the rotor hub to micron-level precision.
The King Stallion's 3-engine gearbox is assembled using ultra-precise aerospace-grade components.
The gearbox undergoes lubrication and durability tests before installation into the airframe. The powerful T408 engines arrive pre-certified, ready for integration with the helicopter's power system.
Okay, that's 75. Verified, mount is secure.
The fuselage begins taking shape inside a multi-story assembly jig designed for maximum accuracy.
Down 5 more inches, slowly. Copy that. Steady, steady. Perfect, lock it down.
The cockpit frame is built with advanced composites and metal alloys for protection and visibility.
This bundle go according to the schematic.
It runs along the upper frame, right past the next bulkhead.
Robotic systems bend high-pressure hydraulic lines that control landing gear and flight surfaces. The landing gear is built to withstand extreme loads during heavy military operations. Crash-resistant fuel tanks are mounted to supply the helicopter's 3 powerful engines. The rotor mast integrates with the gearbox, forming the central rotating power system. Engineers prepare the blade grips that will hold the aircraft's massive 7-blade system.
Right, bring it down slowly. Watch the alignment pin. A little to the left, easy now. Okay, hold it there.
Navigation, communication, and flight control computers are installed in the avionics bay.
Switches are all secure. Good. Initiating power sequence now. Check the readouts.
Initialization complete, looks solid.
Each of the helicopter's 3 engines is mounted and connected to the main gearbox.
Sensors across the airframe monitor performance and ensure safe heavy lift operations. The powerful tail rotor provides stability and directional control during heavy lifting.
A complete structural scan verifies that every component meets aerospace safety standards.
정렬 완료. 2번 작업 계속해도 괜찮습니까? 네, 완병으로 일치합니다. 계속 진행해주세요. 좋아, 이제 고정 시작해.
Fuselage is clear on the left side. Keep it moving at 0.5 meters per minute.
Acknowledged. Maintaining speed and trajectory.
Bring it down 5 more inches.
Copy that. Looks aligned now.
Check the pressure differential on throttle 4. It's fluctuating outside the acceptable parameters.
I see it. Rerouting the diagnostic sequence now.
All right, slowly now. Watch the clearance on the port side.
Looks good. Set her down gentle.
Starboard mount is reading within tolerance.
Confirmed. Data uploaded.
Okay, that one's secure.
Good. Now move the wrench to the upper connection there. Down slowly, watch the alignment.
Looks good from here.
All right, hold it there. We're locked in.
Rotation at 20%. Check the resonance frequencies.
Levels are stable. No abnormal spikes on channel 3.
Solid readings here too.
All systems nominal. Flight controls active.
Output shaft speed is steady at 23,000 RPM. Torque is holding at 5,000.
Good. Let's maintain for another 2 minutes.
Good on the alignment here. Let's lock it down.
Reading confirmed. I have logged the final numbers.
Pressure on sector 4 is spiking above tolerance. We need to check the speed immediately.
I see it. It's climbing fast. All clear confirmed on my side.
Holding
Data looks
steady at
stable.
7,000 psi.
Roger that. All systems green, altitude holding.